So last time we were on this slide, we had discussed the determination or evaluation of properties at the saturated liquid curve and the saturated liquid vapor. Saturated vapor. Okay. So now what will happen if uh, we are not at a saturated liquid phase or saturated vapor phase, but we are somewhere in between. Okay, so for that we had discussed all of this. So we had discussed how we can use another property called quality of the vapor to determine properties. Okay, so we had introduced this property. So for just to revise, for saturated liquid, this property or this quality, what is meant by this quality? It is the ratio of mass of vapor to the total mass of the liquid vapor mixture. Okay. Okay. So we had defined quality for saturated liquid to be 0. For saturated vapor, this quality is 1, and for the mixture, it is somewhere between 0 and 1. Okay, so all of this has been clarified in the last lecture. So if you do not remember it, then go back and listen, study that lecture, and you will have an idea what I'm talking about. Okay, so one thing to remember, that this quality does not have any meaning in the subcooled region or the superheated region. There is no meaning of quality in this region. Okay, so if you are given the quality, either it is 0, 1, or between, this means that you are in this region, or you are at the saturated liquid or saturated vapor line. Okay, so this should be clear. uh, we cannot say that for subcooled liquid the quality is 0. It does not make any sense. Okay, similarly we cannot say that for a superheated vapor the quality is 1. No, it doesn't make any sense. The quality is only defined either for these two curves, these two lines, these two green curves, or the region between the dome. Okay, so let's explore how we can use this quality to this x to determine the properties. Okay, so before starting uh, the next, or this is the continuity of our topic, so let me make you clear something. You should be clear that during phase change, I don't remember if I have told you this in the last lecture or not, but during phase change, if this is your liquid and this is your vapor, so phase is changing, the properties remain constant. Okay, so the property of this saturated liquid remains the same during this process. Similarly, the property of this saturated vapor remains constant. Okay, so what is meant by the properties? यहाँ पर मैं किन properties की बात कर रहा हूँ? I'm talking about the enthalpy, specific enthalpy, the specific volume, the specific entropy. It remains constant during the phase change process. I'm talking about not about the mixture. I'm talking about the saturated liquid and saturated vapors. Okay, these properties will remain constant. However, what is the thing that is changing? It is the quantity of liquid and quantity of vapor. Phase is changing now, so this means liquid is being, either it is evaporating if we are supplying heat, so definitely the liquid phase is changing to vapor phase. Okay, so In other words, the quality is changing. So this property X is changing during the phase change process. Okay. Uh, so this means, for example, at the start of phase change process, if your quality was zero, this means all of your fluid was actually a saturated liquid. So now, with passage of time, this X is changing. That means your saturated liquid is becoming saturated vapor. Okay. It is moving towards the phase of saturated vapor. Okay, so this means from X is equal to 0, now this quality will increase. For example, it will become zero point 0.1. Okay, then it will become 0. For example, 3, then 0.5, then 0.8, and then 0.1. Sorry, 1 whole. So when X will reach 1, it means that your phase change has completed. Now it is a saturated vapor. After this, after adding more heat, we will get superheated vapor. Okay. So between this change of phase, the properties of this liquid, these properties remain the same. Similarly, the properties of this vapor remains the same. Properties ये वाली same रहती हैं, but this X is changing. Okay, this means that the liquid, for example, let's take another example. So if the liquid has a volume, let's say specific volume, for example 0.00001 meter, I'm just giving you an example. Okay, meter cube per kg. Similarly, this is for liquid, so this means Vf. Is there a small Vg that is for the vapor? So it is, let's assume it is 0.126. Uh, we know this is for a given, either for a given temperature, saturation temperature, or saturation pressure. This is hopefully clear to us. ये आपको पता होना चाहिए. You can see example देख लेते हैं just for remembering. So for example, if we are talking about 100 kilopascals for a given saturation pressure, we have a fixed value of Vf and Vg. Okay. However, during this phase change process, when the phase change will occur, the masses will change. Mass of fluid will change, and mass of liquid will change, and mass of gas will change. Okay. The total mass definitely will remain the same. Mt will remain the same. However, as the phase changes, this mass drops and this mass increases. Right? The gaseous mixture or the mass of vapor increases. ओके सो इन बिल्कुल इस अगर मैं आपको सिंपल बात करूं तो इफ़ यू हैड 1 लीटर ऑफ वाटर, ठीक है, बिफोर बॉइलिंग, after complete boiling you will have 1 liter of or in other words, let's not go into the liters, which is volume. Let's talk about the mass. So if you have evaporated 1 kg of mass, so initially this was 1 kg of water. Okay, now after evaporation, this is 1 kg of steam. Okay, so when it was total water, liquid water, X was 0. After evaporation, complete evaporation, boiling, complete boiling of saturated vapor, X is 1. यहाँ तक आपको बात क्लियर है?
Yes, sir.
Okay. Okay, so now what will happen? Now this means uh, the properties of this phase liquid water was same. Let's assume the volume, specific volume was this for the given temperature, saturation temperature, let's say 100 degrees centigrade. Okay, and for the steam it is same, this property is same, but because initially it was all liquid and now it is all vapor, so the overall average value of this Vf and Vg changes. Okay, because we take, if I talk about this whole mixture, vapor liquid mixture during phase change. Okay, so this is the phase change process now. So during this phase change, let's say you are here. So here there will be a mixture of this property, some effect of this property, and there will be some effect of this property. So this means the specific volume of that liquid vapor mixture will be some portion of this and some portion of this. Okay, so let's explain this how we can quantify this. Okay, so the properties of the liquid, saturated liquid, are the same whether it exists alone or in mixture with saturated. ये सारी बात मैंने आपको explain कर दिया. During the vaporization process only the amount of saturated liquid changes, not its properties. The same can be said for saturated vapor. Okay, so a saturated mixture can be treated as a combination of saturated liquid and saturated vapor. Okay, so that mixture can be treated as this combination. The amount of mass for each phase is usually not known. So normally we do not know the amount of each phase. Okay, usually it is the case. We don't know the how much kgs of water is present at a specific period of time during the phase change. We don't know how much kgs of liquid water is present and how much kgs of the steam are present. It is often convenient to imagine that the two phases are mixed well. Okay, so instead of saying that there is some amount of vapor and some amount of fluid, sorry, liquid, we say that it is a good mixture of these two phases. Okay, and अब डेफिनेटली अगर ये मिक्सचर है तो हम ये तो नहीं कह सकते कि इसकी टोटल वॉल्यूम जो है वो स्पेसिफिक वॉल्यूम या स्पेसिफिक प्रॉपर्टी विल बी दिस वी जी और दिस वी एफ. So it is a mixture of these two properties, and we call it the average property or average specific volume. Okay, so this average V average will be some value A times V fluid plus some number B times VG. ओके, सो वी नीड टू evaluate these two things ताकि हम ये फाइंड आउट कर सकें. सो अब हमारा गोल ये है कि हम उस मिक्सचर की प्रॉपर्टीज कैसे फाइंड आउट कर सकते हैं. ओके, बिकॉज दैट मिक्सचर प्रॉपर्टी इज नॉट गिवन इन द टेबल. Okay, so the properties of mixture will simply be the average properties of the saturated liquid vapor mixture under consideration. यहाँ average property का मतलब हरगिज ये नहीं है कि this Vg plus Vf divided by 2. Doesn't mean that. It means weighted average. अभी हम आगे देखते हैं. Okay, so it depends upon how much quantity of saturated liquid is present and how much quantity of saturated vapor. Definitely जो phase ज़्यादा होगा उसका influence properties पर भी ज़्यादा होगा ना. ठीक है. So let's see. Consider a tank that contains a saturated liquid vapor mixture. Okay, so there is a tank like this, a tank. Okay, so we have a saturated liquid vapor mixture in which there is some amount of liquid, saturated liquid, and some amount of saturated vapor. Okay, so the volume occupied by the saturated liquid. Okay, so this is a tank like this. Okay, so here we have some saturated liquid and some saturated vapor. This is not the specific volume, this is the actual volume, meter cubes. Okay, so if this is the total volume of the tank Vt, okay, Vt, it will be equal to Vf plus Vg. Simply कुछ हिस्सा फ्लूइड ने ऑक्युपाई किया हुआ है, दिस लिक्विड is not occupied here and the rest is occupied by the gas. Okay, so the total volume will be this. Okay, so in terms of specific volume, how can I write it? So the specific volume will be, as we know, volume is equal to mass times specific volume. So I hope this is clear. या आपको पहले से पता है कि what is specific volume and what is the actual volume. Okay, so if we multiply the specific volume with the mass, we get the volume. Okay, because specific volume is meter cube per kg, so multiply it with kg to get the meter cubes. Okay, so now how can we rewrite this equation? This is Vf, mf times small vf. Similarly, mg times small g. Okay, so what about the total volume? It will be the total mass of g plus h, sorry, g plus f. This means the total mass of liquid and total mass of liquid and vapor phase times that average volume. Now our target is to find out this V average. ये हमारा टारगेट है. ओके, सो अगर इस एम टी को मैं यहाँ से लेकर यहाँ नीचे ले आऊँ, डिवाइड कर दूँ, इट विल बिकम, लेट मी क्लियर. सो I can, okay, before that I can write this. Remember that x is equal to, what is the value of x? X is equal to mg times m total. Okay, so remember this mt, x quality is defined as this. Okay, similarly, I can write this mass of fluid as mt minus mg. Okay, so m total is mg plus mf. So I can write this mf here as mt minus mg. Okay, so I've written it like this. mg को ऐसे ही रहने देंगे. ठीक है, why I want कि ये पूरी इक्वेशन जो है either mg में लिखी जाए या mt में, because mf की हमारे पास कोई डेफिनेशन नहीं है ना. So that is why हम इसे इस इक्वेशन को in the form of quality लाना चाह रहे हैं. Okay, so after that and after some algebraic manipulation, very easy, it is not very difficult, we can write this equation as, हमने क्या किया, okay, let me just, I've divided this equation with empty, this side with empty as well to eliminate this, and this side as well, empty. Okay, so ये cancel हो गया. We have got V average. Okay, what happened here? Here the empty was cancelled minus mg over empty, so it was something like this. Let me write it. यहाँ पर आपका बच गया 1 minus mg over mt times small vf, plus here is also mg over mt times vf. Okay, so now sorry, this is vg. Okay, so now if I rewrite it, this equation, ज़रा इसको आप लोग खुद भी सॉल्व करें with me so that you get an idea. अच्छा, what is this term? ये टर्म क्या है? दिस टर्म इज, व्हाट इज दिस टर्म? एम जी ओवर एम टी। इसको हम क्या लिख सकते हैं? x, this is the quantity.
X.
Okay, similarly this mg over mt is also representing the quality. Okay, so now I can write this equation as 1 minus x vf plus x vg. Okay, similarly is vf को if I take inside the brackets, so this will be x minus sorry, this will be, this will be vf minus xvf plus xvg. Okay, so ये vf तो लेता है. So if I rearrange this term, I can write it as, so I'm writing it here as vf is equal to vf minus, sorry, plus v x times vg minus vf. These are all small v's, okay? Specific v's. Sorry, this is vg minus vf. Okay, so मैंने इस vf को बाद में लिख दिया and it's इस vg को पहले, that is why there is a plus sign here. So what is this term vg minus vf? What is this term? vg minus vf. So vf plus x times vfg. This is the called the specific, the difference between these two. We write it as vfg. Okay, so this means, so after this we get this value. इस j इस तरह ही है आपके पास. So now this means, what does this mean? So this means for a given temperature or pressure, okay, for a given saturation temperature or pressure, if you know the vf, the quality of fluid, and vf, vg minus vf, so you can find out the value of that average volume. Okay, so this means here, if you know for a given temperature, temperature means I'm talking about the saturation temperature or saturation pressure. So if you know the value of, you will definitely know the VFs and VG, right? So if you know what is the quality of that saturation, saturated vapor liquid mixture, you can find out the property of your system, okay, or the mixture. So according to this equation, um, for a given temperature, or pressure, the vf will remain the same. This vfg will also remain the same, right? This vfg will remain the same, however this x will change as the phase changes. So as the phase changes, so this means due to this change in x, your average volume will change, average specific volume. And not only the average specific volume, the other properties like the specific enthalpy and specific entropy will also change. Okay, similarly I can write this equation like this, where x is equal to v average minus Vf over Vfg. Okay, so let's see what uh, how geometrically we can represent it, or through the phase change diagram. What are these, the numerator and the denominator? What does it represent? Okay, so if we relate it to the PV diagram or TV diagram, both in both cases, we can see that the numerator term, okay, so this numerator term, so this means कि आपके अच्छा पहले इसको समझ लें कि what is meant by this VFG, जो कि ऑलरेडी मैं आपके साथ एक्सप्लेन कर सकता हूँ. V average means कि जिस पॉइंट पर where you are evaluating the property, उस पर आपके प्रॉपर्टी क्या है. Okay, so this V average here, so this V average minus VF, so V average is here and V average is here minus VF. So this magnitude represents the numerator. ठीक है? And what is meant by this VFG? VFG is nothing but VG minus VF, right? So वो क्या चीज represent कर रहा है? This VG and minus VF. So it is representing this horizontal magnitude. Okay, so ये अभी ये बात हमने एक्सप्लेन की. दिस मीन्स कि इफ दिस डिस्टेंस, इफ यू आर स्टैंडिंग एट पॉइंट ए, सो दिस मीन्स ये जो ऊपर ये जो न्यूमिनेटर है इट विल बी जीरो, hence x will be 0. But if you are standing here, it means you are saturated, you have the saturated vapor. So here it would mean कि आपके ये जो distance है v average minus vf, ये इक्वल हो चुका है इसके. सो बोथ टर्म्स विल बी इक्वल और ये कैंसिल आउट होकर आपको x इज इक्वल टू 1 दे देगा. ओके, सो सिमिलरली इसी प्रोसीजर को रिपीट करते हुए वी कैन evaluate the equations for average energy, okay, internal energy, average entropy, average enthalpy. Okay, सो इसको एक जनरलाइज्ड फॉर्म में वी कैन राइट इट एज दिस. So where y is any property, specific property, v, u or h or even s as well. S means entropy. उसकी अभी हम बात नहीं कर रहे. We'll talk about it probably in the last one or two chapters. Okay, यहाँ तक clear है आपको? So now if you are given a saturation temperature or pressure and you know the x as well, means the quality of your vapor as well, you can find out the properties of vapor in the vapor liquid mixture. Okay, so normally we avoid this average word, we just use the word y, means either we are finding out the v, u or h. Okay, so the values of average properties of mixture are always between the values of saturated liquid and saturated vapor. Okay, so ये बात भी आप याद रखें. For saturated vapor liquid mixture, your properties will always be between the properties at saturated liquid and saturated vapor. इससे ज़्यादा नहीं हो सकती. This means कि if your specific volume for um, liquid is, for example, 0.0001, and for the gaseous phase, saturated vapor phase, it is 0.15. So it is not possible कि आपके जो V एवरेज होगा, ठीक है, मिक्सचर का, इट विल बी बिटवीन दीज टू वैल्यूज. ऐसा नहीं है कि इट वुड बी आइदर 0.00001 और 0.000 सॉरी 0.016. ऐसा नहीं हो सकता. इट कैन नॉट गो बियॉन्ड दीज टू रेंजेस. ओके, clear up to this point because we will start an example. G, are you guys with me or not?
Yes, sir. Clear.
Yes, sir.
Okay, let's start. Let's solve an example. So, a rigid tank contains 10 kg of water at 90 degrees centigrade. Okay, so if 8 kg of the water is in liquid form and the rest is in vapor form. Okay, so determine the pressure in the tank and the volume of the tank. Okay, so here we are given the total m mass of the water, mt. A rigid tank contains 10 kg of water. Okay, काइंडली अपना माइक ऑफ कर लें जिसका भी ऑन है. Okay, and the temperature of water is 90 degrees. Okay, so this is that, and this is most probably the saturation temperature. Why? Because he's saying that 8 kg of this water out of this 10 kg is water in liquid form, and the rest is in vapor form. So how much kgs is in vapor form? अगर 10 में से 8 kg liquid water है तो 2 kg. So this is m uh, fluid mf. Okay. Sorry, this is remember this f doesn't mean fluid. मैं उस गलती से कह जाता हूँ. It is a Latin or Greek symbol of representing liquid. Okay. So here the vapor form means mg will be equal to how much? 2 kgs. Okay. यार आप में से किसी ने ऑन किया हुआ अपना माइक काइंडली ऑफ कर दें. प्लीज चेक कर लें जिसका भी माइक ऑन है. मुझे भी नजर नहीं आ रहा है यहाँ से. ओके, सो एज we have a mixture of liquid and vapor, right, at this temperature. So vapor or liquid का mixture at a given temperature means कि your at this point this is your saturation temperature. Okay, so this means that this is your saturation temperature. क्लियर है यहाँ तक? आई अब ये बात तो आपको क्लियर होनी चाहिए. ओके, सो सबसे पहले आपसे क्या कहा है उसने? व्हाट वी नीड टू फाइंड आउट द pressure in the tank. So what will be the pressure in the tank in this situation? Anyone?
जी सर.
What will be the pressure in the tank? पहली चीज हमने फाइंड आउट करनी है प्रेशर.
सर 70.183.
यस, 70.183 वाट. 7 यूनिट भी कहा करें, किलो पास्कल्स. ओके, सो दिस विल बी द प्रेशर. ये पहली चीज हमने फाइंड आउट करनी है, टैंक प्रेशर. दिस why you should be clear at this point. You should be clear why the pressure is this. Okay. Okay, so now we will need, and we also need to find out the volume of the tank. So we are talking about the total volume of the tank. So इसको find out करने के लिए we shall be needing two things, Vf and Vg at this given temperature. So हमें वो बता दिया गया. It is given in the table. So Vf is small v. This is small v. Okay. So this is meter cube per kg. Small v is 0.001036 and meter cube per kg, and Vg is 2.3593 meter cube per kg. Okay. So what shall we do now? ये this is clear. ठीक है, ये मैंने आपको सारी सिचुएशन बता दिया. Why this we know. Okay, no, now we know these values.
सर एक क्वेश्चन है
जी,
ये अभी देख कि अगर हमारे पास 21 बस तो फिर 90 जंप करके वो 100 पे इस तरह है ना।
मुझे आपकी बात समझ नहीं आई, आपकी आवाज़ कट रही है।
सर मैं कह रहा था कि अभी हमारे पास जो टेम्परेचर है वो 90 है।
हम्म।
अगर हमारे पास 91 हो या 92 हो, ये
गुड
टेबल के
क्वेश्चन।
अंदर तो हमारे पास देखे 90 के बाद
गुड
95 है,
क्वेश्चन।
100
यस।
है, इस तरह है ना।
यस, बिल्कुल सही कह रहे हैं आप। देयर इज अ वे, वो तरीका मैं आपको, हाउ वी कैन evaluate दैट, वी यूज लीनियर इंटरपोलेशन। ओके, सो आई विल टेल यू अबाउट दैट इन द नेक्स्ट लेक्चर। ओके, आज की लेक्चर में, दैट हाउ कैन वी evaluate a property for which the saturation temperature or pressure is directly not given, so we can estimate that property. Okay. Okay, so for this but now for this lecture we have this numerical, we have the values, हम उसको utilize करेंगे. Okay, so we need to find out the total volume of the cylinder, so that will be equal to the volume of liquid plus the volume of gas. Okay, saturated liquid and saturated vapor, so that will be mass of liquid times specific volume of the liquid plus mass of the vapor times specific volume of the vapor. So all of these values are given. We know that the mass of uh, saturated liquid is 8 kgs, water का mass 8 kg है, and we have evaluated this value from the table. We have similarly these two values भी हमें पता है. So after solving we get this specific volume, sorry, the total volume of the container. Okay, एक तरीका हमारे पास ये है. Now how can we use, but you will see that normally हमें mass given नहीं होता, okay, in these problems. So we are given the quality of the vapor, या हम किसी तरीके से we can find out this quality. Okay, but here directly by using the masses we can find out the quality. Either use this technique to solve this problem, or the next technique, which is to find out the quality. So the total mass is 10 kgs and the mass of vapor is 2 kg. So what will be the property quality? 2 divided by 10. So that is 0.2. So this means 20% of the vapor liquid mixture is composed of vapor. Okay. So use this equation and solve this equation to get the value for specific volume, and then multiply it with the total mass. You will get the total volume of the tank. Okay, दोनों cases में definitely the answer will be the same. Okay, so definitely आपको ये खुद भी solve करना पड़ेगा, तब समझ आएगी. Otherwise इस तरह बैठ कर lecture देखने से आपको समझ नहीं आएगी. So try these numericals by yourself as well. Okay, so up till now we have discussed saturated liquid, saturated vapor, and today we have also discussed the saturated vapor liquid mixture. Okay, so now we shall discuss the two other extremes, that is compressed or subcooled liquid and the superheated vapor. Now how can we determine the values or the properties of the fluid when we are in these two regimes? Okay, so first of all let's discuss superheated vapor. Okay, so the region of we definitely know कि ये right hand side पर हमारे saturation curve के. Okay, so this region, At the right hand side of the saturated vapor curve, we have the superheated vapor region. Okay, so this region here. Okay, so uh, since the superheated region is a single phase region, ठीक है, हमारे पास we have only the vapor phase. In the superheated region there is no liquid phase. Okay, so the temperature and pressure are no longer dependent properties. इस region में हमारे पास temperature and pressure dependence upon each other वो खत्म हो चुकी है. Okay, so now we have temperature and pressure independence. Okay, so the table property table for this region is a little different than the properties table for the mixture region. Okay, or the saturated liquid or vapor. Here we had, अगर हम इसको देखें, so let me go to the book to explain this. So if I look into the, अच्छा, observe this table, which is the saturated water table. Okay, temperature table. So for every temperature, every saturation temperature, we have a fixed saturation pressure. Okay, ऐसा नहीं है कि for water at 10 degrees centigrade there are multiple saturation pressures, right? Same goes for the pressure table as well. For a given pressure, you have a unique uh, saturation temperature. But for superheated vapors, this is a little bit different. So this means for a given pressure, you can have multiple temperatures. Okay, so इस चीज़ को हम from the temperature volume diagram भी we can understand it by using the TV diagram. Okay, so here, so if you observe it, we can see here we had temperature pressure dependence. For a given temperature, there was a given saturation pressure. Okay, but after this dome, now there is no dependence of temperature on pressure or pressure on temperature. So this means for the same temperature, you can have different pressures, right? You can have different pressures. So this means as we will move here from left to right, what will happen? The gas will expand, the specific volume will increase, and the pressure will drop at the same temperature. Okay, so इस sentence का ये मतलब है. So I hope this is clear. So these tables are little bit different from the saturated water, the saturated liquid tables. Okay, the liquid and gaseous mixture tables. So you will see here you will have for a given pressure you will have multiple temperatures and properties for each temperature. Okay, so normally in this region we need to define the pressure as well as the temperature. So ऐसा नहीं है कि for a given pressure you can say कि for this 0.1 megapascal the temperature of steam will always be 150 degrees centigrade. It could be 150, it could be 1300 degrees centigrade. Okay, however this temperature given in the bracket, it represents the saturation temperature. Okay, so is here we have this saturation temperature. Okay, so I hope this is clear. कंपेयर टू सैचुरेटेड वेपर्स, अच्छा अब हम सैचुरेटेड वेपर की बात कर रहे हैं. वी आर कंपेयरिंग दिस विद सैचुरेटेड वेपर. हाउ कैन वी नो दैट दिस vapor is superheated or not? So as compared to saturated vapor, this is the criteria. Okay, so if your pressure is lower than the saturation pressure at a given temperature, this means you are in the superheated region. Or if the temperature is higher than the saturation temperature at that given pressure, you are in the superheated region. Similarly, higher specific volumes, higher internal energies, and higher enthalpies, all of this for a given pressure or temperature, indicates that you are in the superheated region. Okay, so let me draw इसी को again. I will have to explain it using the diagram. Okay, so if you look here, so अगर हम यहाँ से this for a given temperature, okay, for a given saturation temperature I'm talking about. So here the pressure is P2, right? So if for this given temperature your pressure is less than the saturation pressure, ठीक है, यहाँ पर आगे pressure less ही होगा ना, यहाँ से जैसे जैसे हम आगे जाएंगे. So this indicates that you are in the superheated region. Yeah, for a given pressure, so let's say for this given pressure, if your temperature, this is the saturation temperature, and the temperature of your vapor is higher than this temperature for a given pressure. So this again indicates that you are in the superheated vapor region. Okay. Or if you're so for this temperature and pressure, we have this specific volume Vg. Okay. So if your specific volume is greater than Vg, or your enthalpies or entropies or the internal energy is greater than the given energies enthalpies, then this means that you are in the superheated region. Okay, so we were on this slide. Okay, so I hope this is clear. जब हम numerical solve करेंगे related to this, we will be able to understand it more clearly. Okay, so I think time is over. Yes. Okay, we'll stop here and we'll resume this lecture in the next time slot. Okay, so पहले मुझे stop करना है इसको.